Hi everyone! Today I would like to show you how you can write easier to understand and more maintainable code using JetBrains Rider environment and cognitive complexity extension. What do I mean by cognitive complexity? When we are looking at a code, we see methods, we see classes, and so on. Methods can have different parameters, and inside the body they can have if-else statements, loops, switch cases, and many other things, which in the end will complicate our code. And at some point, this code starts to be quite hard to understand because of the cognitive complexity itself. How to achieve it? By using JetBrains Rider environment and cognitive complexity extension, I will show you that in a moment. Let's look first at the cognitive complexity page in the JetBrains marketplace. So you can see there are not that many details here. On this page, it's just a short description with versioning, and you can note that the rating of it is 4.8 out of 5. So it's rated quite nicely, but still it's not that popular extension if we are talking about the IDE of the Rider. So if you would like to read more about the concept of cognitive complexity, how and why it was introduced, you can click on the link here and it will open you the PDF where it is all described in details. So what it is, how does it differ to cyclomatic complexity, and so on, how you can see it in code, what parts of code will increase this cognitive complexity. And of course, in the example that I will give you, so we will go through, we will create a class in a solution, we will create a method, and we will try to monitor this cognitive complexity of this method by adding different elements. But of course, I can't cover all the elements which you can do with this plugin. I already created some solution for us that we do not waste time on it. If you would like to add this plugin to the Rider environment, you would need to go to the settings of the Rider and go to plugins. So I use the shortcut, but if you would like to do that by your hand, you just need to go to settings by clicking the mouse in the JetBrains Rider environment. Here we have the cognitive complexity plugin. So I already have it. You can add it by clicking install here, and after it is installed, we go to our solution explorer and we just create a new class, and I will name it here for our purpose of the film cognitive test. And now we are in the cognitive test class. At the moment, nothing is different to the state before installing this plugin. So let's add a method here. And this method we will call check. And I would like to add two parameters here. So we will have input parameter A and input parameter B. What can you notice right now is that there is such an icon here. And it shows that there is a cognitive complexity value of 0. So 0% out of threshold 10. And what does it mean? It just in general means that we have nothing in our method at the moment. We have just the name of it, we have some parameters, input ones, but there is no body inside. So let's start to add body inside. Let's assume we would like to add some parameter which is not related to the input parameters. Let's call it param z, and this param z will be 1. So here you can see that from cognitive complexity nothing changed because it's not complicated for our brain. Let's now play around and add something that will increase this complexity, because now we will need to start thinking about it. So we can increase this cognitive complexity based on structure or based on the nesting. So let's add the if statement. And here we can check that if parameter a equals 1, then something happens. But we don't want now to write what happens exactly. When we are now checking at the cognitive complexity, we will see that it's already a value of 1, so 10% out of threshold 10. If you click on this icon here, it will show you in which place this cognitive complexity is being added. So here you see that it's at this place. So we have +1, and you see, if you hover on this +1, that this if statement, it increases the nesting. So that's why we have +1 in the cognitive complexity. Good. So let's complicate it even more. Let's add another if statement. So you see at the moment that it's already 2, and I will explain you in a second why it's 2. So if input param b equals 2, then we do something, but we at the moment don't care what it is. Now we can see that our cognitive complexity is of value 3, and that's true. It's +1 and +2, but you might start wondering why it is +2 here. So if you hover here, it's first of all increased nesting and additional if statement. So you have one for if statement and one for nesting itself. So now we have 3 in total. Let's complicate it a bit more. Let's add another input parameter, which we call input param c, and we add it inside this if statement. So if input param c equals 3, then something. And now you see it's +3, and it's +3 because we have input if statement as the first point here, and then for every single nesting we are adding +1 point. So we have here +3 in total. So our cognitive complexity of this method at the moment should be 6 points. If we are looking at it here, we see that it's in fact 6. Okay, what can we do now? We can say that if this parameter c is equal to 4, then we are doing something. And now you can see, but wait, it was +3 here, now we have just +1. So what happens? So here at this level, we are already at the nesting level. So we don't add another nesting complexities. We are just adding else if, which increases cognitive complexity +1, only +1, because we are already at this part of the nesting. So our method now is having +1, +2, +3, so 6, +1, 7. If we check it here, it's 7. What next? We can, for example, add here another check outside of this ifs, and it will check if input parameter b is 1. So we are going here, checking some additional thing, and of course, as it is at the top level, it's just +1. At the moment we have 80%. You can see that cognitive complexity plugin suggests that this method is simple enough to understand by our brain. And let's complicate it even more. So here we will add a collection of strings, and it will be called input params. And we will iterate through it. So let's use for each and use input params. And now we are having as well +1 complexity, because loop will add it like +1, exactly like the if statement. So of course, if this loop would be nested, so let's say here, it will be +2. Not +1. To check it, we can just copy it and put it here. And you see it's +2. So at the moment, our method starts to be already mildly complex. So mildly complex is already too much. So if you will see such thing inside your code, anything that goes above the threshold 10 means that this code could have been somehow simplified. That's very important to note here. And let's say we have here this for each statement and we will add another parameter. So let's say that if input parameter, of course, the parameter check, if input parameter equals to hello world, then something happens. And of course, it's +2 here, and that's +2 because we are already nested inside this for each. So we are adding +1 for nesting and +1 for this if check statement. If we add here else if, it will be exactly like here above with +1. The same goes with the switch statement. If you add a switch statement, it will increase it +1 at the top level, at the root level. And if it will be nested, it will increase more and more this complexity. And by now you can see it's 130%. It's quite a lot. Okay, so let's say that you would like now to optimize your code somehow, and you say, okay, environment is suggesting me here that, yeah, I might change this if to switch. So let's do it as it's suggested. Look here, it's 130%. And after we are converting it to switch, wow, it's 140%. Why did it happen? Well, it happened because, first of all, we are adding switch statement at this nesting level, which is already quite high. So we are having +3, like before with the if statement. And then we had just else if, and else if added 1 point. And so let's go back for a second to the code that we had. You see here, if is +3, else if is +1. So now if we repeat the suggestion from the environment, switch replaces if and it's +3. But now we have two cases, and these two cases are adding cognitive complexity of 1. So instead of decreasing it inside this method, we increased it by following the suggestion from the environment. So here it did not help. So what can you do is, of course, you can start cutting the things. Maybe it makes no sense to do all these checks inside one method. Maybe it makes more sense to extract method to a separate one. Then you will decrease this cognitive complexity. Maybe in general, this method does way too much. So maybe it makes sense to split the logic of it between different classes, because they are doing things which are completely unrelated. Of course, with our example here, this is just a plain check method, and this is for testing purposes, so there is no business logic or anything around. But normally in your application, there might be a chance that if you spot this cognitive complexity, which is quite high from the level perspective, then it makes sense to rethink the concept of it, because might be that there is some spaghetti inside and that some part of business rules should not be checked inside this method. It can be extracted. So this means that maybe your class is breaking the single responsibility principle or open closed principle. So these are good points to check and validate while seeing this cognitive complexity. And that's all for today's episode. If you use cognitive complexity on a daily basis, just let me know in comments what do you think about it. If you are now planning to start using it after today's episode, I will be very happy. And if I can somehow help you, just let me know as well. And I invite you to watch other episodes which are on my YouTube channel. New episodes are released every Friday at 6 p.m. CEST. Thank you for watching, and see you in the next one.